Going to your next page, when we start looking at, I don't have the formula for lye and lime. Ammonium would be NH3. You can Google those, lye and lime. The worksheet down on the bottom, I can do that with you. That means you're listening to this lecture. Lemons. So we're going to start categorizing everything as either an acid, a base, or neither. Acids, I would say lemon is acidic. Vinegar, that's also a common household acid. Sour milk, nasty. God, I don't know why I want to say that, but I have it listed as an acid. Lye and lime, okay. Those are both things that you would put on. Lye is used to clean, I believe, and lime is something that farmers, or even if you're working out in the garden, you can put lime on your crops or your fields or on your flower beds to try to neutralize an acidic soil. Ammonia is a base. Gastric acid, I wonder what that is. That's A. Gastric acid, that would be the acids found in your stomach. Those have a pH of about 2. So when we talk about a pH scale, again, we go from 0 all the way up to 14. Anytime you get on this half, you're going to be basic. Anything down here is acidic. So what does that mean neutral is going to be? That's going to be at 7. Okay. Gastric acid is about a 2. Super, super acidic. Milk of magnesia, well, that's what you're going to take if you have an acidy belly. Tums, Rolaids, anything like that. You can drink milk of magnesia. That would be basic. Oh, there we are. Tums, B. Green apples, believe it or not, are actually very acidic. So we put in A. Tired muscles, what do we know about that? When muscles get fatigued because you are sprinting or you are doing some powerlifting, you're maxing out on your squat. You know, those are types of exercise that you can't do for long periods of time for like an aerobic activity. Those are anaerobic, and so the waste product that's going to build up in those muscles as you squat or run sprints is lactic acid. Okay, that's the byproduct there. So that would be acidic. Yogurt is also acidic. Okay, again, that is lactic acid from lactose. Oh my word. She insists on sitting right next to me when I record lectures. And water should be neutral. Okay, so properties, tasting sour, we're going to say is acidic. Producing an electric current, they both do. Both acids and bases do that. Turns phenolphthalein colorless. Now, phenolphthalein turns pink in the presence of a base. So if it's colorless, that would mean that it's an acid. A bitter taste is your base. Turns litmus paper red is an acid. Polar covalent bonding, don't even think about that. Who turns phenolphthalein pink? Base. A salty taste, I'd say a base. Don't worry about this one. Turns red litmus paper blue. That's a base. Slippery feel. Soap. Basic. And don't worry about this either. Okay. Now, down on number 3, they want us to draw arrows. Here's what I'm going to tell you. Number 1, identify your acid and your base. And then on the opposite side, whatever was the acid becomes the conjugate base. Whatever was the base, now on the product side will be your conjugate acid. So these two things have to be done first. So when I look at A, who's losing a hydrogen? Well, if I compare reactant side to product side, here's the H that gets lost. Notice it's missing over here. Therefore, this is the acid, which means that on this side, it's the conjugate base. If this was the acid over here, that means water's the base, which means on the product side, that water went to a hydronium, which is H3O, because it picked up a positive hydrogen. So therefore, it is the conjugate acid. Let's take a look at B. Who loses the H? This guy right here. Jesus, she's hawking a loogie. Notice it's missing over there, so this is your acid. If it was the acid on that side, it means it's the conjugate base over here. If HCl was the acid, that means this is the base. And then on the other side, it would be the conjugate acid. Down on C, who loses the H? This one right here. So that's your acid. The other one's the base. If HNO2 is the acid and it loses that H, that means on the product side, it's now NO2. So if it was the acid over here, it's the conjugate base on this side, and then you can fill in your conjugate acid. Next page. Up on top, who loses an H? This guy. That means it's the acid. The other one's the base. If NH4 was the acid, that means it's NH3 on the other side. That makes it the conjugate base. And then fill in your conjugate acid. Who loses the H? This guy right here. That means the other one's the base. HClO is the acid on this side. On the other side, it's just ClO. That means it's the conjugate base. And fill in your conjugate acid. Now, the next part we look at mono, di, tri. Mono means one. Di means two. And tri means three. So we can call acids monoprotic, diprotic, or triprotic, which that means how many H's they have to donate. So if you're looking at this guy right here, H2, do you think that's mono, di, or tri? Good job, everybody. It's H2 means it has two hydrogens to donate, so that would be diprotic. C only has one H. HCl is monoprotic. H3, or phosphoric acid, that's going to be tri. And then here we have H2 again, that would be di. All right, matching area, monoprotic, we just said it means one. So when we look through this list, taste sour, no. Water molecule that gains, no. Acids that contain three, no. Acids that contain one, good, E. Triprotic, we just saw, I read through three, there it is. Because tri means three, that means they have three hydrogens to donate. That's a C. An acidic property, we said that they're sour tasting, and I see that up in A. Base properties, they taste bitter and they're slippery, so that would be F. A conjugate acid. Oops, okay, I got rid of that one. So we're down to B, D, and G. The conjugate acid, is it a water molecule that gains? A water molecule that gains a hydrogen. That means it would go to H30, and because it gained a plus hydrogen, it now has a plus charge. This is called hydronium. So hydronium ion would be B. Okay, that one's off. Let's look at D, a particle that remains when an acid has donated. Well, this is kind of where the wording gets goofy. If it was HCl and it donated an H, that means on the product side it's going to be this. Well, we said if it's the acid on the reactant side, it's got to be the conjugate base on the product side. Therefore, that is D, the particle that remains when the H has been donated. And that would be this guy right here, so that's a conjugate base, D. And then you can fill in G for that one. Good. Oh, good job, Jessica. All right, down on the bottom, let's match these up. Acetic acid is actually just vinegar. That's a like Hachu one on your crazy acetic acid on your Chem Helper. Milk of magnesia. What do you think that matches up with? Oh, possibly magnesium. So we put a 5 there. Sore muscles, we said that's the buildup of lactic acid. Lime, put in a farmer's field. That is calcium oxide. So CaO. Any farmers that can go and look that up on something that they're putting in their equipment and spreading on the fields, you send that picture to me. I'll get you some extra credit. Okay, so that's 6. Oranges. Oranges are part of our citrus family, so where do you think that belongs? Citric acid. And green apples, the acid in that is called malic acid.